this equation, this function. It's a parabola because it's an x squared. I can see that this parabola is going to open downward. It's going to go like this and come down because the value of a is negative. It's a -1. So first of all, I'm going to identify that a is -1. The b term is -10. And c is -24. Okay, so the first thing that we're asked to do in these problems is to find the vertex and the axis of symmetry. So for the vertex, I always start off by finding the x-coordinate. Remember, the vertex is just an ordered pair. So x will be equal to the opposite of b over 2a. And you have to be really careful with your negatives on this. So this is going to be the opposite of b, which is -10, over 2 times a, which is -1. Okay, I have a negative times a negative here is a positive, but then divided by a negative gets me a negative, right? I have 3 negative signs there. So that is going to end up being a -10 divided by 2, which is 5. Okay, so that's the x-coordinate of the vertex. Then I'm going to plug in that -5 into this function for x here and simplify to find out what y value is. So I go negative x squared minus 10 times x minus 24. And I'm just going to put that 5 in, that -5 that I got here, and simplify. So the first thing that you have to do, order of operations, is square the -5. So -5 times itself, -5, is a positive 25, and then I take the opposite. So that ends up being -25. -10 times -5 is a positive 50 minus 24. So don't hesitate to use a calculator if you need to. -25 plus 50 gives us a positive 25. Minus 24 equals a positive 1. So I have the x-coordinate and the y-coordinate of the vertex. So the vertex is at the ordered pair -5, positive 1. So I'm going to graph that. I go from the origin 5 to the left to -5, and then up 1. Okay, now I sketch in my axis of symmetry, which is a vertical line that goes right through that vertex. And that axis line is at, it's an equation for a vertical line, which is just x equals, in this case, it's -5. It's that. Okay, so far I've named the vertex and the axis of symmetry. Now I'm going to find the points on the graph using the 1, 3, 5, 7 pattern, and then we'll talk about the maximum and minimum. So I'm going to use this 1, 3, 5, 7, etc. pattern, except because I know that this parabola is going to open down, it's going to come like this. I'm going to move, every time I move right by 1 from the vertex, I'm going to go down 1, and then the next time I'll go down 3, and then down 5, etc. So first of all, I go right by 1 and down 1 for a point. That's this one. Then I go right by 1 and down 1, 2, 3 for another point. Then I'm going to go right by 1 and down by 1, 2, 3, 4, 5. And that's far enough. So I've got 3 other guide points from the vertex, and I'm going to reflect these across over the axis line. So this one is, I'm 1 away from the axis, so its partner is right over here. With this point, 1, 2, and then 1, 2. With this point, 1, 2, 3, 1, 2, 3. The symmetry makes this easy to graph. Okay, so now I'm going to try and sketch in something as nicely curved as I can with arrows on each end to show that this goes infinitely down. Okay, so there's the sketch of my graph, and now I've got to name the minimum value, because, oops, it's a maximum value because this is pointing down. And so the highest point I get is where y is equal to +1. You just measure it against the y-axis, or you look right here. So the maximum value of this, the highest point on the graph, is at +1. And we get that from that y-coordinate of the vertex. Okay, the domain with parabolas of this kind is always all real numbers. So we use this symbol, which means all real numbers, meaning x can be any value. The range tells all the possible y values. Well, as we can see by looking at this graph, y, we're at y going negative forever, infinitely, but it never goes above +1. The graph will never show any points up here, right? It's not going to suddenly turn around and head upward. So the highest point it ever gets to is where y is equal to 1. Again, there's that. So the range, it's always going to be less than or equal to 1. So y is less than or equal to 1. Okay, the same as the y-coordinate. It's never, you just look at it and you say it's never going to get higher than that. It'll be equal to it or less than it, below it. Okay, so that's it. And I hope that some of these go well for you. Just be careful with your negatives, your negative values. Put them in carefully, substitute them carefully, and make sure you follow the order of operations when you're simplifying. Okay, good luck.